we're going to go ahead and start talking about arc length. Okay. So in arc length, this is looking at like the measurement of this round part of the arc on a circle. Okay. So in this, L represents your arc length. Okay, so I'm going to highlight this purple. Oh, that's not purple. Okay, so arc length is right here. And that represents this piece of the arc right here. Okay, the arc that goes along the edge of the circle. R represents the radius. Okay, that's the length from the center to the edge. That's this one or this one. Okay, it can be either one. And theta is measured specifically in radians. So if you're given something in degrees, you have to convert it to radians first. Okay, this is an angle measurement. Okay, which we should have picked up from the top. All of the degree measurements, which are angle measurements, were converted into radians, another type of angle measurement. Okay, so radians is your angle measurement, and it's this piece right here. And we usually represent it with the symbol theta. I didn't catch that in the screen. Okay, so it's this, like how big this arc is. Okay, so how like wide our angle is. It's an angle measurement. Okay, so it asks us to find the arc length for each arc. Okay, so here we are given the angle measurement and we're given the radius. Okay, so let's go ahead and like highlight that. This is my radius. This is my angle measurement. Okay, so in my formula up here, maybe I should go ahead and do that. I have parts. Okay. Also, this is not quite the same as the solutions that I posted. I'm sorry. The highlighting is slightly different. Go with this. Okay, so I want to fill in the colors that I'm given so that I can, that was even wrong. I'm sorry. Arc length is purple. So we are solving for purple, okay, the arc length or the length of each arc. And we are using this formula. So we have L equals R theta, okay? And we can highlight our respective variables just like we have in our formula that we have written above. Oh, green. Okay, and we want to fill in the colors that we have. We have the green, we have the pink, so let's fill them in. So L is equal to 6 times 120. But this 120 we can't put in. Oh, I need to... Never mind. Everything's going to match because I'm going to repost the solutions. My solutions are done incorrectly. We have to have radians in order to be able to put something in here. Okay, so we need to take this pink piece and we need to convert to radians. Okay, so if we're going from degrees to radians, this means that we need to use our orange formula. Okay. And so we're taking our degrees, 120. I'm multiplying by pi over 180. Now, 120 over 180 is equal to 2 over 3. So this is going to be 2 pi over 3, okay, when I cancel all the stuff I can out. Now, this becomes my new radian measure, okay? This is the thing I need. So I put this 2 pi over 3 in my formula, okay? And now I need to multiply. 2 times 6 is 12. 12 divided by 3 is 4. So my arc length should be 4 pi, okay? And that is the final. So that's from A to B, the arc length, and it's 4 pi radians. Okay. All right, so now we have the diameter of the circle is 24. So our radius, remember, is equal to 1/2 of our diameter, okay? Which means that we have 1/2 times 24, so our radius should be 12, okay? So we should have a radius of 12 here. That's our green piece, and it's in centimeters, okay? And then we have an angle measurement, but it's not in radians, okay? So we're gonna have to convert this to radians. Okay, so we are gonna take 60. We're using the orange formula from the very top. We're taking 60 and we're multiplying by pi over 180. 60 over 180 should give me 3. Is that right? No, that's wrong completely. It should be pi over 3. I'm sorry. Pi over 3. Okay, 60 degrees is pi over 3. So this becomes our true radian measure that we're going to use in our formula. Okay, so now my arc length is equal to my radius times my theta. My radius was 12. My theta was pi over 3. So my arc length should be 4 pi radians. Okay, coincidental that it's the same as the last one. Okay, our radian was the pink. Oh, radius is what this is, and that was our green, and that was the 12. Okay, I'm just gonna wipe that out and fix it because it's me. So R, and that should have been green. Okay, ooh, ugly. Well, okay, so that's finding arc length. I hope that was fairly straightforward. Also, this final answer is 4 pi. The purple highlighter is super difficult to see underneath, but both of these solutions were 4 pi. Okay, all right, let's flip it over. All right, so now it tells us the length of an arc EF is 5 pi, find the length of the radius. So our equation is still L equals R theta, okay? But this time it gives me the arc length. So that means this is my purple piece, okay? So 5 pi goes right here. My radius is green.